Hi guys, welcome back to my channel. Okay, today we will start analysis using ANSYS to solve our previous problem we discussed in our first video. Kindly check the link below to see the video for the program specification. Yeah, we'll be solving this bolted nozzle fletch for the rocket. We are going to model this from scratch. This is the actual. We are going to model this in ANSYS. We are going to define the material. Okay. Then we are going to define the boundary conditions. Then we solve. It will be 3 steps. But my main focus, I won't focus on the modeling. I'll focus on the actual analysis. Okay. This is the ANSYS workbench. The first thing I like to do is to check the units. I like using the units as per program definition. We're using PSI, inch, and yeah, they have inch and PSI. Therefore, I have to make sure that my units they match this inch, yeah, and pound force, yeah, US engineering. Okay. In the future videos, I will illustrate these analysis systems that are available in the ANSYS. I will illustrate each each of them using real life examples. I like using an example so that you can be able to appreciate the importance of the ANSYS and the strength it has. Okay. Uh, for now, for example, there's eigenvalue buckling. We'll do some analysis later. Explicit dynamics, this one of my favorite, whereby we model. This one is used to do the analysis of short time impasse. For example, a car crash. When you are driving in a car, then you hit a barrier. Those short time impasses or dynamics we can be able to model here. Okay, for example, when you fire a bullet and you want to do the analysis of the maybe the component that the bullet will hit during a very short time, we do that analysis using explicit dynamics, very powerful tool. We'll do an example. This is for the fluid flow. You want maybe to determine, maybe you want to model a heat exchanger. Okay, you want maybe to do the analysis of aeroplane airfoil. We can now do using the fluid flow. We are going to do an example. They are very powerful. We'll do an example in the future videos. Harmonic acoustics, modal acoustics, and static acoustics. These are for the noise. For example, you want to do the noise analysis in maybe you have a theater and you want to determine the best position to position your speakers so that you can have a smooth noise or smooth sound in the theater room. Maybe in a recording room, you want to know the best position to do the recording. Therefore, static acoustics are very handy, but unfortunately, these ones are not my expertise for the noise or sound. We won't do this, but you can do your research. Maybe they might help you in one way or the other. This for the harmonic response. We'll do an harmonic response together. We'll combine together with random vibration, model analysis, response spectrum. We are going to model vibration analysis so that we can be able to determine the damping coefficients. We can be able to determine overdamped and critical damp. All those parameters that are associated with damping. I don't want to go into a deeper details for now, but when we do an actual example, we are going to do a deeper explanation. For the rigid dynamics, very handy, very important. We want to do the modeling when, for example, when a car is moving, you want to see how the parts behave with respect of another part in motion. Maybe you can do the analysis of the suspension, how they are behaving, the point of failure. You can be able to predict the point of failure at the motion. Therefore, the word rigid means it is something in motion. Motion, rigid dynamics in motion. Anything that will be exhibiting motion. We'll do a very nice example in this for you to understand application of rigid dynamics. Static structure. This one is the, for example, when you are sitting on a chair, we when the load applied on the chair or when the load is applied on a beam and the load doesn't change over the time, a constant load, maybe you apply 5,000 newtons. If the load is constant, we call it a static analysis. Okay, for example, a tank that is full of water, the water doesn't change level, maybe assuming the tank is holding the same level of water, we call that static analysis. And we are going to start by this one. We are going to conduct static analysis in the deeper details to solve the Bolton nozzle fridge. Steady thermal and thermoelectric, we are still going to solve this. Okay, for the conduction, convection, radiation, we are going to see how we can solve anything about heat here. Maybe you want to do analysis for boiler and you want to determine the best material for insulator. We'll do a thermal analysis. Then you have a very important topology optimization, one of my best, which we're going to use to, we can use topology optimization in case you want to minimize the weight of the component. Maybe you want to reduce weight by 50%. At the same time, by not compromising the strength. Minimize the weight, but do not compromise on the strength. We conduct topology optimization so that we can remove the areas which has less effect. Okay, we'll do a very good example on that. Transient means the load varies over the time. For example, a car moving on a bridge. The bridge experiences different loads at certain time. Maybe at time 1 second, it experiences load at point A. After 5 seconds, the car has already moved to section B. Whenever there's a change of load or whenever a load varies with time, we call it transient. And we'll do a very good example. We're going to do a bridge example to illustrate transient structural analysis, and still we'll do some transient thermal. Yeah, and we have a tab of machinery fluid flow. Just stick around. This is the best place for you to learn ANSYS from beginner to an expert level. And I'll be using real life examples for you to understand. And I will be attaching all the examples for you. This Word document, I will attach it to the video description so that we can practice with this over the time. Okay, let's now start. As I said, I like making sure my units are in what I'm using. For now, I'm using a PSI. I have to make sure my units, they match my parameter units. Okay, we start by selecting the analysis. We said we are going to conduct static analysis. We left click, drag to the screen. I like renaming. Yeah, for this bolted nozzle. Okay, I like bolted nozzle fridge. Yeah. Yeah, like that. We have 7 sections. Now, the first one, it shows the type of analysis. If you pick something else, this is a static analysis, therefore it has to be displayed here. Okay, the first one indicates the type of the analysis. The second one, it is where we are going to define the material. It is like a library for the material. Okay, in this case scenario, our material is stainless steel with this various the Young modulus, position ratio, and coefficient of thermal expansion. We are going to define those values in engineering data. Okay, then after there we are going to model our geometry.